going to see Class 8 ICSE syllabus Mathematics Chapter 1 Number System Lesson 3 Session 6. So today we're going to see the continue or rest of the portion which we already learnt. Before we move to the topic, let's see the solution for the assignment problem. These are the solution for your assignment problem, so kindly check it. Okay, now today we're going to see about to find a number which is not a perfect square using division method and properties of a square numbers. Okay, now we move to the topic. To find the square root of a number which is not a perfect square using a division method.
In the previous class, we learned about perfect square and how to find a perfect square using the prime factor method and division method. Today we are going to see how to find the square root of a given number which is not a perfect square using division method. Can anyone say 14 is a perfect square or not?
It is not a perfect square.
Yes, very good. How did you find that it is not a perfect square?
Because its exact square is not obtained.
Yes, very good. Now let us see in detail how to find the square root of a given number using division method.
Now we're going to see to find the square root of a number which is not a perfect square using division method.
Let's see the example for to find the square root of a number which not a perfect square using division method. So let's see the example for it. Find the square root of 24.789. Correct to two places of decimals. So from this, in order to find the square root up to 3 places of decimal, we have 3 pairs of digits after the decimal. So for the purpose, let me consider 24.729 is equal to 24.729000. So addition of any number of zeros on the right of a decimal fraction does not change its value. So from this we're going to do the division method. So 24.72900. So let's take 4 into 4 is 16. So when we subtract we get 8. When we double the 4 we get 8 9. So 89 into 9 is 801. So let's take bring down the third pair. We get 9. So 9 8 7 into 7 is 69.00. When we subtract this we get 28100. So when we multiply we get 19884. So the remainder is 8216. The quotient is 4.972. So from this quotient they given that up to 3 places of decimal. So since the third term is 2, so it is lesser than 5. So let we take it consider it as 4.97.
From this, let's see the another example. So according to this, they given that find the least number that must be subtracted from 2433 so that the remainder is a perfect square. So let's use our division method. So let's consider 24 32 as a pair. So To solve this, let's take 4 into 4 is 16. So the balance is 8. So when we double 4, we get 8. So let's take 89 into 9, we get 801. So when we subtract 833 minus 801, we get 32. So from this, they clearly said if 32 subtracted it's from 2433, the remainder will be a perfect square. Let's check. So from this, since 2433 minus 32, we get 2401. So, and we know that root 2401 is a perfect square of 49. Now we are going to see a properties of a square number. In previously we already learned the properties of addition, subtraction, likewise. In this we are going to see the properties of square numbers. Let's see.
Students, now we're going to see the properties of square numbers. So the first property is the ending digit, which must be in the numbers like 0, 1, 4, 5, 6 or 9. So the ending digit is also called as unit place, which means if the square of 11 is 121. In the same way, 25 square is 625. 4 square is 16. So these are set to the first property. Now we are going to see the second property. According to this second property, they given that a number having 2, 3, 7 or 8 at its units place is never a perfect square. For example, I given some certain numbers which is not belongs to the second so they are 12, 22, 32, 13, 23, 17, 27, 18, 28. It goes on because it's a unit place. It's as 2, 3, 7, 8. So these numbers are not said to be the second property. Next we move to the third property. According to this third property, they given that if a number has 1 or 9 at its unit, then the square of these number is always as at its unit place. For example, I taken 1. So the 1 square is. Now we're going to see the fifth property. A fifth property, they given that if a number ends with n zeros, its square ends with 2n zeros. For example, a square of 30 is equal to 900. So the given number as 10, the answer as 2 zeros. So from this the condition is satisfied. In the same way, let's take the square of 300 is as 2 zeros, the given number as 4 zeros. So it is also the n number, its square ends with 2n zeros. So the condition is satisfied. Now we're going to see the sixth property. A perfect square number leaves the remainder 0 or 1 on dividing it by 3. So from this, let's see an example. 9 is a perfect square number, and it divided by 3. The remainder is 0. In the same way, let's take a 16 is a perfect square of 4 square. So when we divide this number by 3, the remainder is 1. So from this
from this both perfect square, it's a reminder as 0 or 1, then it satisfies the sixth property. Likewise, let me see if any perfect square number, if it has 0 or 1, then it's said to be the sixth property. Next, we're going to see the seventh property. So, seventh property for any natural number n. So, from this, we consider any natural number we want. So, when it proves the formula, then it's said to be the seventh property. So according to this, now I going to consider the n as 7. So from this we know that the n, when n is 7, then n plus 1 is 8. Therefore 8 square minus 7 square is equal to 8 plus 7 is equal to 15. So when we get 8 square minus 7 square is equal to 15, the same way 8 plus 7 is also be a 15. So according to this, condition is satisfied. So in the same way, let's see for 15 square minus 14 square is equal to 15 plus 14 is equal to 29. So from this the condition is satisfied, so it's said to be the seventh property. Now let's see a condition. The condition is the sum of 5 n odd numbers be like 1 plus 3 is equal to 4. In the same way, 2 square is also 4. In the same way, let's take 1 plus 3 plus 5 plus 7 plus 9. When we add these terms, we get 25. In the same way, 5 square is also 25. So, likewise, 1 plus 3 plus 5, etc. till n numbers also, the n square is equal to the number. So, let's see now the second property. In the second property, they given that for any three natural number p, q and r, if p square plus q square is equal to r square, or p square plus r square is equal to q square, or q square plus r square is equal to p square, then p, q and r are known as Pythagorean triplet. Now see with an example. Now I consider a natural number p as 3, q as 4 and 5, r as 5 are a Pythagorean triplet. So now from this condition, 3 square plus 4 square is equal to 5 square. So 3 square is 9. So 9 plus 4 square is 16. So 9 plus 16 we get 25. Of course, 25 is a perfect square of 5. So from this, the condition is satisfied. In the same way, if we take 5 square plus 12 square is equal to 16 square also, it also a Pythagorean triplet. So from this, it also a condition which to prove the seventh property.
So if you have any doubt, let's check it.
Now let's see the example for the properties of square numbers. So from this question they given that which of the following number will have a 6 at their units place. So according to this condition, we already know that from the property 4, the first and third one, its unit place as 6, because in the fourth property itself we learnt if the number ends with 6 or 4, it has a unit place value is 6. So the answer is 1 and 3 has its unit place, has 6 in their unit place. Now let's see another example. In this they given that if a number ends with 3 zeros, how many zeros will its square numbers have? So according to the fifth property, we know that according to the fifth property, we have 3 zeros. So when we double the term, so 2n is equal to 6. So our answer is 6 zeros. Let us see a quick recap. What are the things we learn in this chapter? Okay, now can anyone say identify 144 is a perfect square or not? Okay, now can anyone say identify 144 is a perfect square or not? Yes, of course, it is a perfect square because 144 is equal to 12 into 12. So it is a perfect square of 12 square. Now anyone can answer this question. Give an example which is not a perfect lesser than 20. Except 4, 9 and 16, other numbers are said to be not a perfect square because we know that 2 square is 4, 3 square is 9 and 4 square is 12. So when we say not a perfect square, we can say that 2, 3, 5, 6, 7, 10, etc. So these are said to be not a perfect square. Now can anyone find the square root of 7744 using division method? Yes, we can find it. So can anyone tell?
Yes, very good. So the square root of 7744 is answer is 88. Now can anyone state the Pythagorean triplet?
Yes, very good. For any three natural number p, q, r, if p square plus q square is equal to r square, or p square plus r square is equal to q square, or q square plus r square is equal to p square, the number p, q, r are known as Pythagorean triplets. Now, can anyone give an example for the second property? But the number is not be a 2, 3, 7 or 8. The other things are said to be the second property. Now, solve this thing. 37 square minus 36 square is 23. Yeah, that's right. Students, these are the assignment problems, so kindly note it down and submit within the time. Students, kindly join in the Google Classroom as soon as possible because still some more are not joined in the Google Classroom. These assignment marks are included in your internal marks. So kindly join in the Google Classroom. This is our class code. Thank you.